Hello everyone, I think you guys are doing well in your places and welcome to this Kubernetes lecture series. By the way, I am Suhith Jayasekara. We start with the basic overview of the Kubernetes cluster architecture. We first look the architecture at a very high level view and after that I will discuss each component in detail in future lectures with hands-on experience in Azure. I am going to use a ship scenario to understand the architecture of Kubernetes. The main key purpose of Kubernetes is to host your application in the form of container in an automated way and enable the communication. So let's look very high level view at the Kubernetes architecture. So I am going to describe about the architecture using these lecture slides. These lecture slides are uploaded to the GitHub. The link is in the description. So we have two kinds of ship. One is cargo ship. This one is cargo ship. Another one is the control ship. This one is the control ship. Cargo ships. Cargo ships do the work and control ship doing the controlling part. Working means loading containers to the ship. And controlling means the process of deploying the containers. Kubernetes cluster contains nodes in a private data center or cloud platform or any virtual machine. The nodes are relating to the cargo ships. The worker nodes in the cluster are the ships that can load containers. And the whole process of deploying containers to the work node done by the controlling node. That's mean controlling ship. The whole process of loading containers to the cargo ship is done by control ship. So the somebody means the control ship. The control ship is not just deploying the containers. It's plan how to identify the ships, track the location, and whole managerial process, etc. done by the control ship. And it's related to the master node. The control ship is the master node. And the cargo ship is the worker node. So control ship is master node and cargo ship is worker node. This whole process is done by several components. The several components are Kube API server, Kubelet, Kube proxy, Kube scheduler, control manager, etcd cluster. So I am going to give a brief view of these terms: API server, Kube proxy, Kubelet, Kube scheduler, control manager, etcd cluster. So when I consider about the etcd cluster, etcd's job is to store the data about how many containers being loaded and unloaded from ships on a daily basis and what time it's loaded. All of this data saved in a very highly available database, etcd database. Basically, the main idea is about etcd. etcd tracks the ships in your cluster. That's mean worker nodes, how many containers are in the worker nodes, and what time we are going to deploy worker nodes into your cluster. So when a ship arrives to the master node, using cranes, they deploy the containers to the ship. Using cranes, they deploy the containers to the ships. So this This is done by queue schedule. As the scheduler identify the right node to place a container on based on the containers, resources requirements, the worker node's capacity, or any other policies or constraints such as range, toleration, or node affinity rules that are on them. All about these are identified by queue schedule. There are different officers in the dock that are assigned to special tasks or departments. That means the control manager. For example, the operations team take care of ship handling control likewise. Similarly, the Kubernetes we have the control manager. Control manager available that take care of different areas. Three kind of control managers. The node controller take care of the nodes. The replica controller take care about replicas, and operation control take care about the operation of the whole cluster. They are responsible to manage the controlling part of the cluster. So we have seen different components like different offices, the different ships, and the different data stored in the etcd cluster, and cranes, schedulers. Now discuss how they are communicate each. The Cube API server. The Cube API server is the primary management component of Kubernetes. The Cube API server is responsible for orchestrating all operations with the cluster. This man, Cube API server, this man is responsible for all operations in the cluster, all orchestration process in the cluster. It exposes the Kubernetes API, which is used by external users to perform management operations on the cluster, as well as the various control to monitor the state of the clusters and make the necessary changes as required, and the worker nodes to communicate with the server. Those things are done by Kube API server. Now we are working with containers. These are containers. Containers are widely spread in everywhere. So our applications are in the form of containers, in the different components that the form of the container. On the mass node would be hosted in the form of containers as well. The DNS service networking solution can be deployed in the form of containers as well. So we need these softwares that can run containers, and that is the container runtime engine. You want to run the containers in your worker nodes, you need a container runtime engine. The popular one is the Docker. So we need the Docker to install in our cluster. So as well as the master node, you have to install the Docker. If you wish to host the control plane of components as containers, now it doesn't always have to be a Docker. The container runtime engine not should be always have to be Docker. The Kubernetes supports other runtime engine as well as containerd or Docker. Let's now turn our focus into the cargo ships. The cargo ships. These three. Basically, in the cargo ship there is a captain. The captain is responsible for the managing all activities in the ships, that means cargo ships. Now the captain of the ship is the kubelet. Ship refer to kubelet. Ships equal to kubelet. The kubelet is an agent that runs on each node in cluster. Kubernetes, the captain of the ship. Captain of the ship equals to Kubernetes. The Kubernetes is the main component which is used to communicate with the Kube API server, with the master node. The Kube API server is consisting, and Kubernetes is responsible to communicate with the Kube API server and get the instructions from master node. So, if you think there is a web application in your production, it's hosting a one worker node and the database is hosting a one worker. So, if you want to communicate with these two worker nodes, it can be done by enabling the kube proxy. That means the kube proxy. Kube proxy is giving chance to communicate with each worker nodes, as well as with Kube API server. Kube proxy is located in each worker node. So, enabling Kube proxy in each worker node, you can enable the communication within the worker nodes. So, this is the overview of the cluster architecture. Then we will summarize it. So, when we consider about the Kubernetes architecture, we have two nodes. One is master node and another one is worker nodes. Master node consists Kube API server, Kube scheduler, etcd cluster, Kube control. And worker nodes contain a runtime engine, Docker, or whatever runtime engine, Kubelet, Kube proxy. Kubelet is the ship captain. Kubelet is responsible to communicate with the master node using Kube API server. Kube proxies are enable the communication within worker nodes, and it is hosting each and every worker nodes. And Kube scheduler is doing the part of deploying the rest to the relevant worker nodes. And etcd cluster is storing the container data in a very highly available database. And Kube control manage doing the controlling part of the master node. The node control is doing the controlling the nodes, and replica control is controlling the replicas. I am going to discuss about replicas in future lectures. And control manager. Control manager is doing the controlling things in master node. So, this is the very high level view of the Kubernetes architecture. I think you guys get a brief idea about the Kubernetes architecture. So, that's all for today. So, you can contact me through LinkedIn. And thank you. I am Suhith Jayasekara. Have a nice day.